On here, I'm going to be going over the practice for success for the right triangles test this Friday. Focus is going to be on the evens. On question 2, we see that we have a 45-degree angle, which means by default the other angle will also be 45 because of the 90. So we have a 45, 45 special right triangle. And the formula states that the legs each have the same value represented by the variable x. And the hypotenuse is going to be x times the square root of 2. For this problem, if the side across from 45 has a value of 14, that means this x will also have a value of 14. And then my hypotenuse, which is represented by the variable y, is going to be my leg value, which is represented by the variable x in the formula, times the square root of 2, which means y is equal to 14 square root of 2. On question 4, we're talking about the diagonal of a square. So if I draw in a square and I input the diagonal, it says that this diagonal has a length of 18 feet, and we're asked to determine the perimeter. So we know a square has all the sides are congruent, and we also know that it consists of a 90-degree angle on all the corners. This diagonal is going to bisect the 90-degree angle, which means we have a 45-degree angle and another 45-degree angle with our last 90. So once again, we are looking at a special right triangle, 45, 45, 90. So each leg is represented by x. The hypotenuse is represented by the square root of x times the square root of 2. If the diagonal has a value of 18, then what that means is that whatever is represented by x square root of 2, it's equal to 18. We need to figure out what the x is so that way we can determine the perimeter. To do this, we're going to go ahead and solve by dividing both sides by the square root of 2. And that's going to leave us with x equals 18 divided by the square root of 2. And we remember we don't ever want to have a radical in the denominator. So we have to rationalize this. And we do this by multiplying by 1. But we're going to disguise the 1 as a square root of 2 over the square root of 2. Because anything divided by itself is always 1. This leaves us with x equals 18 times the square root of 2 divided by 2. Because the square root of 2 times the square root of 2 is 2. Those square roots will cancel each other out. And then once again, we don't want to leave our answer like this either because our 18 over 2 can be reduced. 2 goes into 2 once and 2 goes into 18 9 times. So our final value of x is going to be 9 square root of 2. If you remember the pattern from earlier in the unit, we did say if your hypotenuse is represented by a value that does not have a square root, the shortcut would be to take that hypotenuse, divide by 2 times the square root of 2. 18 divided by 2 is 9, and then we multiply it by the square root of 2. So coming back over to the picture, the side of the square is 9 square root of 2. Because we're looking for the perimeter, we're going to go ahead and take 4, because the square has 4 sides, times the 9 square root of 2. The 4 and the 9, when multiplied together, comes out to 36, and we leave that square root of 2. So we have a perimeter of 36 square root of 2 feet. On question 6, we're being asked to identify the altitude of an equilateral triangle with sides that measure 24 units each. Okay, so the altitude is going to be like the height, and we always take this at 90 degrees, and because it's an equilateral triangle, it's going to end up going through the vertex, which splits this whole 60-degree angle into 30. This is 60. So we're looking at a special right triangle of 30, 60, 90. So I'm going to go ahead and draw the formula off to the side. When you have a 30, 60, 90 special right triangle, the side across from 30 is represented by x. The long leg across from 60-degree angle is going to be x square root of 3, and the hypotenuse is represented by 2x. So when we come back and we take a look at our equilateral triangle, we know the side of the triangle is 24. This side is represented by the hypotenuse, which is 2x. 24 is 2x. If I want to know the value of x, which would be the side across from 30, that's here, that's going to be half of 24, which gives us 12, which makes sense because 12 plus another 12 gives us the whole side of the triangle, which is 24. The question is wanting to know the altitude. The altitude here is represented by the long leg. The long leg is going to be x square root of 3. Our x value is 12, which means our altitude is going to be 12 square root of 3. Okay, on number 8, we're talking about a weather balloon that is tethered to a weather station. So here, nothing special. I kind of sketched the picture. Here's our weather station, our building. Here's the string to the balloon. And it tells us that this string to the balloon has a length of 45 square root of 2 feet. And it's making, this string is making a 45-degree angle with the station. It wants to know how high above the station is the weather balloon. So I'm looking for this distance here. This would be like a 90-degree angle. Because it's 45, we're doing that special right triangle, 45, 45, 90. The legs are going to be congruent. Each leg is represented by the variable x, and the hypotenuse is going to be x square root of 2. Because in our picture, the hypotenuse is represented by the length of the balloon, which is 45 square root of 2. We can quickly identify the x, which is the number in front of the square root, is 45. So our answer is going to be this weather balloon is 45 feet above the weather station. Okay, number 10. What a fun one. Here we have two triangles that are connected to each other. And one of them is a 45, 45, 90. And the other one's a 30, 60, 90. So we're going to use both of our special right triangle formulas to figure out the length of AB. With this first one, 45, 45, that means this angle here is 90 degrees. And our formula tells us for 45, 45, 90 special right triangle, each leg is represented by x. The hypotenuse is represented by x square root of 2. So when we come over and we take a look at our picture, we can see we have a leg because it's across from the 45. So this 12 is the same here, which means our hypotenuse is represented by 12 square root of 2. So now we're going to transition and take a look at our next triangle, which is a 30, 60, and this would be 90. So we're going to use our second special right formula. And this says when you have a 30, 60, 90 special right triangle, the side across of 30, opposite from 30, is x. Our long leg, which is across from the 60-degree angle, is x square root of 3. And our hypotenuse is represented by 2x. So when we take a look at our picture, we're now focused only on this second triangle. We see the hypotenuse value is 12 square root of 2. So that's represented by 2x, which means our x value is going to be half of 12 square root of 2, which gives us 6 square root of 2. And then the question is asking us to find AB. AB is across from the 60-degree angle, and the 60-degree angle says you take x and multiply by the square root of 3. So our length of AB is equal to our x value, 6 square root of 2, times the square root of 3. We can go ahead and join what's under the radical. So AB is going to be equal to 6 square root of 6, because 2 times 3 is 6. Square root of 2 times square root of 3 is square root of 6. We can't break that radical down any further, so this would be our final answer. On question 12, we're asked to identify the value of x and y. In looking at the picture provided, we see that we have a 30-degree angle and a 90-degree angle, which means it's a special right. The side opposite of the 30-degree angle is represented by our value x. To find the hypotenuse, we're going to take this value and multiply by 2, because that's what it tells us in the formula. The hypotenuse is going to be 2x. So my x value is going to equal 2 times 14 square root of 3. When we simplify, we get 28 square root of 3. Then our next step is going to be to go find the value of y. Y is across from the 60-degree angle. Across from the 60-degree angle is represented by x square root of 3. So we're going to come back to that x value of 14 square root of 3. And we can determine our y is going to equal this 14 square root of 3 times another square root of 3. Y equals 14 square root of 9. 9 is a perfect pair of 3's. So basically, this square root of 3 times square root of 3, they undo each other. So what we're really doing is y equals 14 times 3, which means y has a value of 42. Question number 14. This is very similar to a question we did earlier. Find the height of an equilateral triangle. Remember, height is the same thing as altitude. In this equilateral triangle, all the sides have a measure of 32 meters. So remember, if it's an equilateral triangle, that means all of my angles are congruent. And if my angles of a triangle have to add up to 180, that means each angle by default is 60 degrees. If we're looking for the height, that means we want 90 degrees perpendicular from the base, and it's going to end up going through the vertex. So we have a 90-degree angle, a 60-degree angle. That means this left half has an angle degree measure of 30 degrees. This gives us another special right triangle. And our formula says the hypotenuse is represented by 2x. The angle opposite of the 30-degree angle is x. And the side across from the 60-degree angle is x square root of 3. So in our picture for our equilateral triangle, the side of the triangle is represented by 2x. So our first step is going to be to find that value of x. So we cut 32 in half, we divide it by 2, and we get 16. Our short leg is 16, which means our value of x is 16. Now we can go ahead and find our altitude. Our altitude in the picture is represented by the long leg because it's across from that 60-degree angle. Across from the 60-degree angle in the formula, that side is represented by x square root of 3. We know our x value is 16, which means our altitude or our height is 16 square root of 3. Question 16. Here we have a right triangle. We know the angle. This is our new favorite. This is where we're going to use trig because it's not a special right triangle. I do not know all three sides, which means I can't use Pythagorean theorem. We're going to go with trig. So trig is the SOHCAHTOA. So is sine opposite over hypotenuse. Cosine adjacent over hypotenuse. TOA. Tangent is opposite over adjacent. Our first step is going to be to identify our angle. So here is 50.1 degrees. From here, we label our triangle. Across from our angle, opposite, is represented by X. Across from the 90-degree angle is going to be our hypotenuse. And then the side next to our angle is our adjacent. So we've labeled our triangle. We have our angle identified. Now I'm going to go ahead and circle the side that I know and the side that I want. And I can see we're looking at the adjacent and the opposite side, the A and the O. So I go to my formula. A and O is represented by TOA. This is tangent. So that means tangent of our angle, 50.1, is equal to our opposite, which is X, divided by our adjacent side, which is 5. We're solving for X, which means I want to isolate the X, just as you would any equation. To get the X by itself, we're going to multiply by 5, because that is the inverse of dividing by 5. These 5s are going to cancel out, which leaves me with 5 tangent of 50.1 gives us our X value. From here, you're going to type it into your calculator. Now remember, you are not the only one who uses these calculators. You always want to go back and double check that your calculator is in degrees. If you're already in the calculator screen, you take a look at the top left corner. You should see the letter D, E, G. If you do not see that, you need to go into your settings and change it. Once you type that into your calculator, you should get a value of 5.97993. Now, if we're rounding to our third decimal spot, this 9 is what we're going to look at. The number after is bigger than 5, which means this 9 goes up. But since it goes up to a 10, it's going to bump the 7 in front of it to an 8. So we're looking at 5.98. And this makes sense because our angle B is going to have a value less than angle A, which means the side across from B should be a number smaller than the side across from A. And it is slightly. 5 is smaller than 5.98. Question 18. Here's another one. We have a right triangle. It's not a special right triangle. We know one angle and one side. So we're going back to SOHCAHTOA. We're going to go ahead and identify our angle, which is 37 degrees, and then label. So opposite of 37 degrees is our X. Across from the 90-degree angle is our hypotenuse. And then our side next to our angle is our adjacent. Once we have our triangle labeled, we're going to circle what we know. and what we're looking for. So we're focused on the hypotenuse and our opposite side, H and O. This gives us our sine trig function. So we set it up. Sine of our angle of 37 degrees is going to be equal to our opposite, which is x, divided by our hypotenuse, which is 10.3. We need to solve for x. So instead of dividing by 10.3, we're going to multiply both sides by 10.3. This makes the 10.3's on the right cancel out, leaving us with our x. I'm going to go ahead and flip this around. X is equal to 10.3 sine of 37. Same thing, go ahead and type this into your calculator. Remember to verify you are in degrees. And you should get x has a value of 6.199 if I round to the third decimal spot. And then just double check, yes, is this number less than our hypotenuse? And we can see, yes, 6.199 is less than 10.3. On question 20, we have another right triangle. This one has an angle measure of 60 degrees, which means it is a 30, 60, 90. If you would like to use your special right triangle and do, you know, you have your x square root of 3 and 2x. You want to use that formula to help you find the value of x here, the length of BC. You are more than welcome to do so. If you don't like that, you are welcome to come back and use SOHCAHTOA. You can do whatever you're more comfortable with. Even the problems that I went over earlier, where I used the special rights, if you wanted to use trig, the SOHCAHTOA, you are more than welcome to. When you're taking your test, if your answer choices are in with the radicals, you could simply type your answer choices into your calculator and evaluate and see which one gives you that same decimal. On this one, I'm going to go ahead and continue with trig. So I have my angle, and I'm going to use that to label my triangle. So across from 60, opposite of 60 is my opposite. Across from the 90 degrees, the hypotenuse. And then next to my 60-degree angle is my adjacent. From here, I'm going to circle what I know and what I need. I'm looking at the hypotenuse and the adjacent, H and A. This gives me cosine. So cosine of 60 degrees equals my adjacent, which is x, over my hypotenuse, which is 11. Once again, we need the x by itself, so we multiply both sides by 11. This makes the 11's on the right cancel out. So I now have 11 times cosine of 60 equals my x value. Type that into your calculator. And for those of you who are using your special rights, you already know your answer. X has a value of 5.5. If you chose to go with your special rights, we know that The hypotenuse is represented by 2x. Our short leg, which is across from the 30-degree angle, is x. Half of 11 is 5.5. Question 22. For these problems, we're asked to find the value of theta, which is the angle. We're looking for the angle given the sides of a triangle. This one we're going to have to use trig. We're going to use inverse trig. So I'm going to go ahead and write the formula. I'm going to identify my angle and use that to label my triangle. My 11.9 is my opposite. Across from C, my 90-degree angle is my hypotenuse. And then 10 is my adjacent. Okay, so I know my opposite and I know my adjacent. O and A. O and A is TOA, so I'm using tangent. Tangent of theta is equal to my opposite, which is 11.9, divided by my adjacent, which is 10. Because we're looking for the angle, we're going to use the inverse, because that's what you do when you're solving. You use inverse operations. So theta is going to be equal to my inverse of tangent. So in your calculator, you're going to use the one with the -1 exponent. And then we have 11.9 over 10. And that's, type that in, you get your answer. So theta is equal to 49.9585. I'm going to go ahead and round to the nearest whole degree, which gives me about 50 degrees. Okay, so on 24, once again, this is another trig. We're looking for angle B. So I've identified the angle. Now I'm going to use that to label my triangle. So segment AC is our opposite. 5 is representing the hypotenuse. And 4 is our adjacent. From here, I'm going to go ahead and circle what I know. So I know my hypotenuse. I know my adjacent. H and A, that is cosine. So cosine of theta is equal to my adjacent, which is 4, over the hypotenuse, which is 5. Because here we're looking for our angle, we're going to do inverse. So that's cosine with the -1, 4/5. And you just type that into your calculator. And you get your answer. Rounding to the nearest whole degree, I get theta is about 37 degrees. Okay, on number 26, we have a 12-foot ladder, and it's making a 54-degree angle with the ground. So this ladder is leaning against a building. So I don't draw the best. So here's my ladder. My ladder is 12 feet. It's making a 54-degree angle with the ground. And we are looking for how high is it reaching against the building. Okay, So I know it's a 90-degree angle here. So we're going to use trig because it's not a special right. Using my angle of 54, this is the angle. I'm going to label my triangle. X is my opposite. 12 is my hypotenuse. And then the ground would be my adjacent. I know what the hypotenuse is. I also need the opposite. So I'm looking at H and O. That gives me sine. And this time I know my angle, so I do not need to use inverse. It tells me sine of 54 degrees is going to be equal to my opposite, which is x, divided by my hypotenuse, which is 12. In getting the x by itself, we're going to multiply both sides by 12. This leaves me with 12 sine of 54 equals my x value. We type that in, and we get x. I'm flipping it around. X has a value of 9.708. If I round to the third decimal spot. So on question 28, we're looking for the angle of elevation. If we're looking at Mrs. Bishop's cat June, who's 12 inches tall and is casting a 17-inch shadow. So here I've already set up the picture, and I have my trig function, SOHCAHTOA, written out. And gonna label the triangle. So the height of the cat is representing our opposite, and the shadow is our adjacent, because this would be our 90-degree. Which means we are focused on the O for opposite and the A for adjacent. O and A would be tangent. And because we're looking for the angle, this is where we use our inverse. So tangent of whatever x is equal to 12 over 17. So when we type this in our calculator, our value of x is going to be the inverse of tangents. We're looking for that -1. 12 over 17. You can go ahead and type that in, and you get your answer. Remember here, we are rounding to our nearest whole number. So it's going to be about 35 degrees. On number 30, we're talking about a ship, and it's detected possible treasure. The angle of depression is 22 degrees, and the ship is 85 meters above the bottom of the ocean. So I kind of sketched a little picture here. Given our angle, labeling the sides, this would be 90 degrees. We have the adjacent, and we're looking for the hypotenuse. So that's A and H. That's going to be our cosine. So cosine of 22 degrees is equal to 85 over x. In this one, when we're solving for x, the first thing we need to do is get it out of the denominator. So we do that by multiplying both sides by x. This leaves us with x cosine of 22 equals 85. And now we're going to divide both sides by cosine of 22. Now we have our x isolated. X is equal to 85 divided by the cosine of 22. And you type that into your calculator. We're going to get a value of about 91.676 meters. All right, good luck on your test.